Piecewise function is where you have a function and it's in pieces. Piecewise function. I'm telling you, every time I introduce a new term to my students, I'm like, mathematicians, we are not super creative. We are a very literal people. So the piecewise function is a function that's divided up into pieces. So you have to graph it in pieces. Hi, I'm Sarah. I've been a STEM teacher for 20 years and I like to make math engaging and fun and not so scary for everyone involved. If you want tutoring, micro tutoring, Cameo, one-on-one Zoom, or in person, click the link and do the stuff and let's make it happen. So if we have this f of x, okay, f of x, we're gonna have this whole function, again, that's in pieces. And it's gonna be in pieces just sort of like when things are, or when you're in a different, when you're in like a different sort of like area of the graph. Okay, so I'm gonna start with just like a 2-piece function. So let's do like x plus 3 if x is greater than 1, okay? And then I'll say if x is less than or equal to 1, then f of x will be, I don't know, negative 2x minus 4. Yeah, I'm just making this up, okay? So f of x is x plus 3 when x is greater than 1. It's negative 2x minus 4 when x is less than or equal to 1. So if I were to ask you what is f of 2, right? If I were to ask you like, what's f of 2? Well, you would say, okay, well, 2, the x value is greater than 1, so f of 2 would be 5. I would use this function when x is greater than 1, plug it in, right? And you get that value. But if I asked you what f of negative 3 is, now it's less than or equal to 1. So I'm going to use this function down here. So I would have, let's see, negative 3 times negative 2x minus 4. So I've got negative 2 times negative 3, which is positive 6, minus 4, which is 2. All right, let's see. Oh, my voice is going. That's not good. Okay, so when you're looking at these, I'm going to leave this up here so we can see. And that's a really good question that like when you plot these, when you graph these, is it going to have an open or a closed dot? So you want to look at where the ending points are, okay? So again, I like to do these when I've got these, when I make these little charts, right? X plus 3 when x is greater than 1. So what I'm going to do is here, and like, yes, I know that there are easier and quicker ways to graph, but remember, I'm here to make math a little less scary. So that's why I always try to relate it back to something that's familiar, something that's doable, right? So yes, I could just go through and I could say, well, the slope is 1 and the y-intercept is 3, so I know it's here, and then I'm going to erase it. But I want to go back to something that's familiar. So we can always go back to these charts, again, regardless of what the function looks like, right? We want to make sure that we're going through here, okay? So x is greater than 1. So I'm only going to pick values. I'm going to pick it as 1 because, first of all, I want to know where it starts, right? And then, I mean, it's a linear equation, so I can just pick 1 and 2. Okay, I know it's not going to go too haywire, but I might as well just do 3 points. Why not, right? So when x is 1, x plus 3 is 4. When x is 2, 2 plus 3 is 5. When x is 4, 4 plus 3 is 7. Okay, so when x is greater than 1, I'm going to be following this line. Since this is x is greater than 1, oh no, I lost my x over there. Oh no. Oh no. Okay. All right. Since x is greater than 1, I'm trying to get everything like so you can see it all. Okay. X is greater than 1. It doesn't say or equal to, right? Since it says just x is greater than 1, I'm going to have an open circle because it doesn't include that point, right? When x is actually 1, it's going to be on this line. So my first line that I'm going to do, which is my pink line, okay, I'm going to do, so x, when x is 1, or, you know, for the starting point, I know it's not actually 1 and 4, but we're going to put an open circle, 1 and 4, okay? So when x is 1, we go 1, 2, 3, 4, and I'm going to put an open circle right there, Okay, now I am way exaggerating this, right? I'm exaggerating this because it's a dry erase marker, and also because I want to make sure that you guys can see that it is an open circle there because it's not included. The line, when x is 1, that value isn't actually the value that we would use. Okay, now for the rest of these, I'm just going to use smaller points because I'm just really mapping out where my line's going to be, right? So I had 2, 5, and then I've got 4, 7. So my line is going to go here. Now remember, I am not going to connect my line all the way down here because it doesn't go past that point, right? So I am going to, now it does keep going this direction, so I can put an arrow there, right? So any value for x that's greater than 1 is going to be along that line, okay? Any value that's less than or equal to 1 is going to be along this line. So let's do blue for this one, okay? Once again, I'm going to use my handy dandy T-chart, okay? So we say x and y. And again, I know this is going to be a straight line because it doesn't have any exponents or radicals or anything like that. So I know it's going to be a straight line. I'm going to start with 1 because that's where my line's going to start, right? That's where this piece of the function is going to start. So when x is 1, I've got -2 times 1, which is -2, minus 4 is -6, okay? Now I need to choose values that are less than or equal to 1. So I got to start going to the left on the number line if we think about that, right? Maybe I'll do -2, right? So when x is -2, I have -2 times -2, which is +4. +4 minus 4 is 0. Okay, and then I'll just do one more for good measure. I'll do -4. Why not? Okay, got -4. So -2 times -4 is +8. 8 minus 4 is 4. Okay. All right, so now we're going to plot this. Now, because this is less than or equal to, that means that that's going to have a closed circle because when the value of x is 1, it's that point. Okay. So I'll just use, oh, there we go. There's that skinny little blue marker. Okay. So at 1 and -6, we've got 1 and 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. Yep. Okay. So that's going to be a big solid point down there. Okay. And then I'm going to plot the rest of my points. So -2, 0. Ooh, this is a steep line. -4 and +4. Okay. So now this, I'm going to connect the dots. But again, I'm not going to go beyond my boundary, right? Because this is a function that's in pieces. So we're going to go right along here like this, like that. Okay. And that is a piecewise function. That's mathed up.